evaluate the integral of 4x cubed plus 5x squared plus 9, all divided by x to the fourth plus 3x cubed, from 1 to 3. The first question we have to ask is the denominator degree more than the numerator degree? And it is. So we can start the method. The method starts with us factoring the denominator. Now, usually fourth degrees are difficult to factor. Cubics are too. But what we have here is the ability to be able to factor out. So x to the fourth plus 3x cubed, we can factor out an x cubed and be left with x plus 3. So we factored it. The next most important thing is that you have to recognize what you have in hand. There are only 3 types of terms you can have from your denominator. The first is a linear term that's raised to the first power. The second type is a linear term that's raised to a higher power. And the third type is an irreducible quadratic term. So what do we have? We have a linear term that's to the first power. That's our x plus 3. And what you have to recognize is that x is kind of like a linear term itself. It's x, is x cubed is like x minus 0 cubed. Think about it like that. So it is a linear term that's raised to a higher power. It's the third power. So once you recognize what you have, that'll tell you how to decompose it. It's our job to take our original integrand and decompose it into the appropriate fraction with the correct numerators. When you have x cubed times x plus 3, then you're going to have a constant over x cubed, another constant over x squared, and another constant over x. 3 separate fractions coming from the one term. And then don't forget about the fourth term, d over some x plus over the x plus 3. And so that's how it decomposes, and now it's our job to chase down those constants. How do we do that? It's our job to put the fraction, where there's 4 fractions, to put these 4 fractions back together into one fraction. And then when we do, they'll have the common denominator, and their numerator should match. I have this old numerator here, this original numerator of 4x cubed plus 5x squared plus 9. Well, when I put together these fractions, I'm going to have a numerator from multiplying by the terms that they're missing. A is missing the x plus 3 term. Now B is missing the one of the powers of x and the x plus 3 term. C is missing 2 of the powers of x and the x plus 3 term. And D is missing the 3 powers of x. By the time we put that all back together, we'll have the original numerator. Okay, so that comes from putting the fractions into one. Now we have to chase down what these constants are. When we do it, what we need to do is let x equal the numbers that would make your denominator 0. Not because dividing by 0 is good. It's definitely bad. We're not dividing by 0. This is a statement that is true for all values of x. In particular, if we pick values that make these terms 0, then what will happen is that it'll wipe out some of these terms. We don't have all the constants to solve for at one time. Letting x equal 0 is a smart choice of x. Not just because it's easy to plug in, but because it'll kill every term that has an x in it. This x that's in the b term, this x that's in the c term, this x that's in the d term, to a power that is, then we don't have to worry about those, and we just focus on the a term only. And then on the left hand side, we'll just have a 9. So 9 is 3a, or a is 3. Great. Next, we would choose to let x equal -3. Why? Because it's going to kill any term that has an x plus 3 in it. It might be difficult for the left-hand side, but we'll deal with it. It kills the a term. It kills the b term. Okay. It even kills the C term. And we're left with just a D term. On the left-hand side, I mean, yeah, we have to take negative 3 and cube it. That's 27 negative. And then, we have to multiply that by 4. If you have to, just go off on the side. In fact, multiply that out. 27 times 4 is 108. Okay, so we have a negative 108, and then a 45 here with the 5 times 9, and then another 6 on top of that is a 54. Another 9 on top of that, sorry. And then on the right-hand side, we have a negative 27d. Why negative 27? Because we took this negative 3 and cubed it. We take the negative 108 and 54. That'll give you a negative 54. And then conveniently, that goes in and makes d equal to 2. I'll try to pick problems that have integer values of d, because the fractions would just complicate things. And so it's bad enough we have to deal with all the algebra. It's helpful not to have fractions. We have A and D. Now we need to go get B and C, but there are no more smart choices as far as like things that will kill immediately all the terms. So let's see what happens. After you run out of choices as far as the ones that will kill the terms, then you should just pick things that are easy to plug into. It's easy to plug a 1 in. So we know that A is 3, we know that D is 2. Let's plug a 1 in. On the left-hand side, it's just adding up the coefficients, 4 and 5 and 9. On the right-hand side, plugging in a 1 is pretty harmless. And so what we end up with is 4A and 4B and 4C and a D, all added up to give me 18. So we know the values of A and D. Let's plug those in. We know that A is 3. We know that D is 2. Plug it in. What will end up happening is we won't directly get B or C. We'll get a relationship between B and C. 4 and 3 is 12. We have the 12, we have the 2. We put that together, we have a 14. Move the 14 over to the other side by subtracting it. And we can, at this point, basically factor out the 4. All the 4's kind of cancel out. And it basically tells us that B plus C should be equal to 1. Okay with that? So factor out the 4 from everywhere. We have B plus C, and then we have 4 equal to that. We divide by 4. And then we end up with B plus C is 1. Alright, great. So that doesn't tell us exactly what B and C are, but it has a relationship between them. It tells us that if we're trying to find B, we must take C away from 1. 1 minus C is B, subtracting C from both sides. The next information is going to tell us what one of them is using some kind of substitution or elimination, and we'll be able to track down both of them. The next wise choice would be x equals 2, just because it's something that I wouldn't pick a negative if I had cubics. The cubics and the negatives tend to make a problem, tend to cause a problem, and so I would just choose x equals 2. That's my advice. So we have cube the 2 and square the 2 on the left hand side. Plug the 2 everywhere on the right hand side. And just be really careful. What we're looking at is a 5 on the A, a 2 times 5, a 10 on the B. Here's a 5 here on the C, but then there's another 4 here. And then this guy has an 8 on him. On the left-hand side, we have that 4 times 8. We have a 5 times 4. That's a 4, sorry, it doesn't look like it. So that's what we're looking at. Let me erase that. I didn't know it was going to get in the way. So we have 4 times 8, 5 times 4, 5 times A, 10 times B, and then we have the rest of that, 20 times C and 8 times D. It seems a mess, but it's not that bad if you just take your time. You have to be you have to write neatly, and you have to be careful. You can't be sloppy with your negatives and your powers. You just need to be a good sort of bookkeeping type of person to make it through these problems. This is just bookkeeping. Careful analysis here. 32 and 20 and 9. We know that A is 3. We know that D is 2. Let's plug those in. It'll give us 15 for 5 times 3 and 16 for 8 times 2. And then putting the left-hand side together, that's a 61. We have a 32 and a 29, or a 42 and a 9, a 52 and a 9, however you want to do it. We get a 61. 15 plus 16 is 31. We can subtract that over and give us 30. Okay. But we know the relationship between B and C. We know that B is 1 minus C. We can use the substitution method to solve these two equations here. We can plug in the fact that B is equal to 1 minus C. We can plug that in. And then distribute the 10. 10 minus 10C. And then after that, what will happen is we can then combine things together, and we'll have positive 10C, and we'll move this 10 over and have 20. So C is 2. Great. Knowing that B is 1 minus C, we even have B right away. B is negative 1. Wonderful. So what comes next? Well, we have to put everything back together. Finish the problem. We know A, B, C, and D. Put them all back together, and we have to integrate correctly and finish the problem off. All right, now, how do you integrate 3 over x cubed? It's not a natural log. You need to treat it as 3x to the negative 3. Same thing for x squared in the denominator. Treat it as x to the negative 2. Now for the others, though, those are just logs because they're to the first power. So 2 over x stays as 2 over x. 2 over x plus 2 stays as 2 over x plus 2. And now we're ready to integrate. Power rule on these first two guys in reverse. And then the other guys will just be logs. LNs. Okay, so we get x to the negative 2 over negative 2, x to the negative 1 over negative 1, and then we get 2 log x and 2 log of x plus 3. Absolute values in there, of course. And our integration is from 1 to 3. Sorry about that. Okay, great. So we plug it. Well, let's simplify first. This doesn't look quite ready yet. Let's put this x squared on the bottom and deal with these negatives here. We're talking about negative 3 over 2x squared. And we're talking about a positive, because of these two negatives, 1 over x. And I recommend, you don't have to, but I recommend putting these two guys together. Because the coefficients match, what we can do is factor out the 2 and be left with the log of x plus the log of x plus 3. Technically inside of absolute values here. And so what we could do is put them together by multiplication, and that's what we get here. X times x plus 3 in one log. It'll make things easier for us. All ready? Now let's plug the 3 in. Every place we see an x. And plug a 1 in. Every place we see an x. What happens is this 3 will cancel with the negative 3 from the numerator. And then this guy is a 6, so 3 times 6, that's an 18. These guys are just 1s, so that's just a negative 3 halves and a positive 1. And over here, we just have a 4. All right, so we have negative 1/6. This guy's a 1 when you cancel. Negative 1/6. Positive 1/3 plus 2 log 18. And over here, we'll have a negative 3 halves, a positive 1, and 2 log 4. My recommendation next is to put stuff that looks alike together. Go ahead and distribute this negative across and lose the square brackets. We'll have a positive 3 halves and a negative 1 and a negative 2 log 4. And the other guys stay the same. And then put these guys that are, not logs together. We just put them right next to each other. So we have negative 1/6 and positive 1/3. Next we should write positive 3 halves and negative 1. And now these two guys that have logs, once again, they have the same coefficient. I know 1 is negative, of course, but we take out the 2, and that'll leave you with log 18 minus log 4. That's desirable, because then we can put those two into one log. Okay, great. it'll be the log of 18 over 4. Keep the 2, though. Don't forget about the 2. The 2 is definitely still there. And then on the other guys, just combine them into one fraction with the common denominator of 6. So negative 1 over 6, and then multiply by 2 here and here to get 2 over 6, and multiply by 3 here and here to get 9 over 6. And then this 1, don't forget about that. It's hard to see because it's not a fraction, but it's 6 over 6. Altogether, you have 7 and 11, 4 over 6. And these guys, you know, it can become 9 over 2. Okay, and then finally, reduce this 4 over 6 to be 2/3. And then sometimes you'll see this, they'll put the power up here and make this 9 over 2, the whole thing squared, or 81 over 4. So 2/3, the natural log of 81/4, is the answer to this problem. Good job.